Hi, everyone. Thank you so much for joining today. My name is Madigan Johnson. I'm the head of communications at Data Friendly Space. Just a couple ground rules before we get into the session. So please keep your microphone on mute throughout the time unless you're asking a question. We encourage you to introduce yourself in the chat and tell us where you're joining from. And if you have any questions, also please include them in the chat and we'll get to those at the end of the session. We're really excited today to show you about the Gannet virtual assistant and the quantitative analysis using HAPI data. So without further ado, I'm going to pass you over to Nurjid Orozco, who is our Chief Product Officer at Data Friendly Space.
Thanks, Marigan, and welcome everyone. Happy to be here with you today, and thanks for joining. As Marigan mentioned, the idea of today is to show you, for those that probably are not aware of Gannet, what Gannet is, and also new functionality, new that is already in the system for the last 6 months. That is the quantitative data analysis using the humanitarian API data. So let me just very briefly tell you what DFS, what we do at DFS. So basically, we provide digital tools and actionable data for social impact organizations. We have partnered in the past with global NGOs, with UN agencies, and we have been developing tech tools in the sector for more than 8 years now. Let me just jump into what Gannet means and kind of the reason why we are here today. So Gannet started 2 years ago, actually, I think by this time as a pilot, and the idea was to kind of democratize the access of data to humanitarians. Today, Gannet is a suite of tools using AI. We know that when crisis happens, all the data is scattered. It's sometimes challenging to start looking what's new in Relief Web, what's new on the media. So the idea with Gannet is that these tools provide the humanitarian practitioners access to that data almost in real time. Today, Gannet is ingesting more than 1,000 documents on a daily basis from qualitative data. And we started integrating the humanitarian API from HDX to bring quantitative data as well into the system. The idea is that, and we will see a demo just in a couple of minutes, how you can start typing questions to the system and you will get answers based on this information. So before jumping into the, let's say, demo, the Gannet deep dive is a functionality where humanitarian users can go and start using Gannet to retrieve both quantitative and qualitative. We have on the left what a manual analysis looked like today. You need to, for example, you will be getting information. You are interested in getting data sets from IDPs, population numbers, food prices. The normal flow is that you may need to go to HDX, find the data set, download the CSV, filter it by date or by other, let's say, disaggregation purposes, clean the data, and then analyze. And this needs to be repeated across the different data sets that you will find. With Gannet, the idea is that this functionality and this feature will give you, in a matter of seconds, depending on the complexity of the task, those responses, both mixing qualitative and quantitative data. So what's available today in Gannet and in HAPI? HAPI today has 13 real-time humanitarian indicators across 5 critical data domains. We have them here. Anything from affected people, climate, coordination, food security and nutrition, population, and geography. All of those different domains, they have their own data sets, and these data sets also have information from multiple countries. Not every country is mapped into each of those indicators or data sets, but you will find that information as well in Gannet. For each of those data sets, you will find geographical drill down, for some of them down to admin 2, and also regular updates as they become available in the website. So with Gannet and the deep dive functionality, the idea is that you can start building cross-indicator searches, for example. What happens if you mix food prices with humanitarian needs or rainfall? and you start kind of asking those questions to the chatbot. That's the first one. The second is that you will be also able to do some temporal analysis, meaning that the HAPI stores information not just from the last or the updated month, but or last updated, let's say, data set, but it also stores kind of historical data. So in that case, you can also ask the system to do some temporal analysis in that case. As I mentioned, geographical drill down to admin 2 for some of them. And we also gave you the opportunity to kind of download the raw data directly from the virtual assistant. So yeah, probably many of you now are asking yourselves, okay, how does it work? So right now, we kind of have this quantitative engine, and we summarize it in 4 main steps. The first one is to understand the need from the user. So let's say the user asks for, I don't know, an historical trend in the population numbers or IDPs in certain country. The system first identifies, and we have many agents or a couple of agents kind of working together. And the first is that identifies the endpoints that are needed from HAPI. So identify that information, also extracts countries or regions, the geographical information that is relevant here, determines which is the time range. If you are talking about the previous 6 months or the last 5 years, it has that information also kind of into consideration, and then validates if that data is available in HAPI, and then decide if the response would be a hybrid response, what we call a hybrid response, which is mixing quantitative and qualitative data, or it's just qualitative based on the qualitative information that is available in case HAPI doesn't have that information. Then the system starts fetching the data. It calls the Humanitarian API with the endpoints that have been selected and start retrieving that information. All of this, if there are multiple endpoints being needed, all of this in parallel. And then, for example, you can bring together IDPs, funding, figures, and food security at the same time. And again, all of this is based on the frequency of updates of the information uploaded into the HAPI. The third step is that the agents start analyzing that data. So all of that data is loaded into what we call an analysis database. The AI writes and validates SQL queries. Everything is mapped into SQL queries, and we have a recursive or iterative process where the agents start building those queries until they find kind of the answer to the question from the user. It's also self-correcting in the process. I will just explain that in a minute. And of course, respects the specific rules of the data sets in HAPI. I will just give you also an example. And finally, on the fourth step, it responds, basically meaning once you have the table or the figures, the AI synthesizes all of that in a narrative answer, and it's streamed in real time. And as I mentioned, all the raw data on those tables are available for download. The built-in data quality safeguards, and here's where I would like to kind of provide some examples of how that iterative and self-correcting process works, is that first, the AI checks every query against the HAPI data rules before running it, and we are not sending invalid requests to reach the API or the API endpoints from HAPI. The second is that if a query fails at some point or returns unexpected results, the AI rewrites and retries automatically. And this process goes up to 15 different trials after we kind of go in this gradient process until we get kind of the answer. The final is that in HAPI, you will find multiple data sets, as we have seen, and each of those, they have their own rules. They have sometimes disaggregation. They have multiple sectors accounted. So here, basically, what we are telling the agents is, please avoid any duplication or avoiding kind of double counting anytime that there is a disaggregation, or no need to kind of some IPC people in need across different sectors, these kind of caveats that are proper of each of those data sets. So before jumping into the demo, I would like just to invite Nico Tamagnone. He is our senior AI engineer. He will explain a bit more for those that are probably more technical, just in 1-2 minutes, how that works before going into the demo. Nico, over to you. Thanks.
Yeah. Everyone, I want just to summarize some detail and what actually happened under the hood. The agent, or let's say the final step after retrieving and fetching the data from the humanitarian API, is mainly based on a sequential graph agent that is composed mainly of those five step. Very to in a very simple way. The first step is to just list and get the schema of the data that was retrieved, that is converted from the API in some SQL table in memory, and then it starts a recursive graph that has Najid already mentioned. It has a maximum of 15 say cycles, where the first step, the most important one, is the generation based on the schemas of the tables of SQL queries. So it's a, let's say, text to SQL. This SQL then is checked in a very simple way, in the sense that the query is run and it checks if it gives some result. If the result is good, so then is running again without rewriting and executed. After the execution, the result is embedded in the history of the LLM, let's say, chat history. So presenting the table with all the result of the query. And then a decision step is performed, in the sense that if the result of the query is and respond answer to the user question, the graph stop and a general final answer is generated. Instead, if the user query, for example, in cases where the request by the user is complex, it continue the cycle and retry and regenerate other queries in respect maybe of other tables in the database, and so on, with a maximum of, as I said, of 15 steps. The last step is just a summarization of all the result of the different queries performed for giving then a final narrative based on the quantitative data. So yeah, this is pretty much how it works. That just a couple of more technicalities is that, of course, here is completely based. I mean, the user query doesn't need to give some specific SQL or other details, but everything is generated and performed by the LLM agent itself. So yeah, thank you, Nate.
Thanks to you, Nico. Great. So let's jump into the demo and kind of the practical use cases. But before going there, I want you also to show you kind of the new website. It was launched officially yesterday, and I think kind of marks these 2 years of process and journey with Gannet. So in the website, you will find the different products that are available today. The virtual assistant, that is the one containing the HAPI. We have situation hubs, probably for those that are aware of automated reporting, the workspace, anytime you want to have your organization private data, just isolate it and be able to fetch information from it. The data explorer that I will just show in a sec. And we are also, as DFS and with Gannet, open to work on your bespoke solutions if you need to integrate them to your current flows. So as I mentioned, I mean, the 13 different endpoints are available in HAPI, but yeah, probably you may kind of wonder, okay, how does it look like if I want to have kind of the overall idea of how the countries are represented and which of those data sets are available. So you can explore that directly in Gannet.ai/explorer. You will get some guidance here of what's available in this dashboard. And basically, we know that AI builds on transparency. So right here, you will be able to find the total number of documents, qualitative documents that are fetched in the knowledge base of Gannet. So this is more than, almost now 530,000 documents that we have fetched for Gannet. You have a set of filters here at the top that you can play with if you want to kind of, narrow down your search. But basically, what I would like to show you here is that you can hover over the map and you will see the number of HAPI data sets that are available for each of the countries. So you will see in a color kind of a scale those data sets. Of course, you have other kind of metrics here, the numbers of articles that we are ingesting daily, and kind of a fit with the latest results. But let's say that you are interested in Sudan, for example, and the response in Sudan. You can go directly to the Sudan, let's say, country page, and a couple of things will happen here. You will get, information about the data availability in regards of those different data sets that we have seen or endpoints. Also with the geographical disaggregation, if it's just a national level, admin 1, admin 2, you will get also kind of a comprehensive analysis of the languages and the articles that have been recently added to this country in a specific. The last 12 months of how the information, at least from qualitative data, has been kind of being fetched into the system. And then I think which is the most interesting part here for those that are more, dealing with data and processing data, you will have access to the different endpoints right here. So the idea is that you can click on any of these endpoints and you will get a sample of the information that these endpoints have available. So, for example, you can go for food security, IPC, and this is live. You can go and play right away with it. So you will get a sample of the 10 most recent rows in this case with the different columns of what's available. If you are interested in getting information or extra information about, let's say, asking questions about it, you can just go here, click, and be redirected to the virtual assistant, to the chat. You can either create a chart and see it in a graphic way, again, with a sample, not every single data that is in HAPI, but we created a sample, in this case, the 10,000 rows, and the same thing for maps. For those that have geographical kind of disaggregation, you can see the maps as well. So again, this is just to show and to give users the ability to explore what data is available in Gannet and how it's kind of being always referencing back to the original sources. So being conscious of time, the idea is to be very quickly, I will present 2-3 different examples, and then we can just open the floor for any questions that you may have. So for those that are probably new to Gannet, this is how the interface look like. The first time you will land, you will see this kind of view as any other chatbot or a conversational interface today. Very similar here. Main differences compared to, let's say, Claude or GPT, and also to be clear here, we are not competing with them. This is actually, Gannet is what is called a RAG system, a retrieval augmented generation system, that is built, on top of a foundational layer. So we benefit from the progresses or advances in Claude, in GPT, and others, and we kind of just make sure that this data that you have in the Data Explorer is kind of, the responses are contained in that data and always referencing the original sources. So it's humanitarian focused. You will have the opportunity to do two types of searchers. The first one is the quick flight, and the second is the deep dive. In the deep dive is the one that we are interested today, which is basically taking both qualitative, quantitative data. You can apply filters to it. You can select if is there any country of interest. You can select it, any kind of date interval as well, or sources. We have categories that you will also find in the Data Explorer in regards of, I just want to only have access to data from Relief Web. So you select Relief Web as one of the filters, and then you will be kind of gathering, or the system will be just taking into consideration those documents. Because of time, I just prepared some examples here. So let me just start with this one. For example, here, based on the most recent flood events in Mozambique, I need a detailed quantitative analysis that covers the following aspects. So we have everything from humanitarian impacts, poverty and vulnerability metrics, climate and environmental data, economic effects, and also please use the most recent available data from the news, highlighting kind of the developments or official updates from the information. After a couple of seconds, sometimes minutes, depending on the complexity of the task, this is what you will get. So you have all the information here with an executive summary. You can, of course, as you do with other systems, you can start being more specific in your prompts, and you will get here kind of the information that is always traced back and updated as you request the system to perform. Again, remember, this is taking both qualitative data that is out there from news, local news, media, Relief Web, UN governments, and then the quantitative data that is available in HAPI. So this is kind of an example, very comprehensive response. Always we source the information back. So you have here kind of the main sources. You see some of them from Relief Web. You have also here, for example, the poverty rate, the operational presence, the national risk, baseline population, all of these data sets coming directly from the HAPI. And you can download them here. If you click on it, it will be automatically selecting the specific dates, Mozambique in this case, and it will be ready to be downloaded. Of course, as Nico was mentioning, we know that giving probably an extra step of explainability will be ideal, and that's why we are also now working on the citation process. And the citation process just gives you the ability of two things. The first one, always trace back the original source and kind of the specific chunk of information. But second, give you also the information on how the SQL queries were written. Let's say that you want to download the data by yourself and replicate what Gannet has done. So you can just follow here and let's say follow the steps. So first filter using the where on the location code dimension with this specific, let's say, variable, in this case, country, aggregate, in this case, there is no aggregation, and then sort order by, and then it kind of gives you the information. So we are not just providing the output as a final answer, but also letting users know how each of those, let's say, charts or tables, in this case, sorry, has been built also for users to be able to replicate that if needed. So yeah, being conscious of time, I think we have 6 minutes left. And sorry, I know we know it's a short one, but yeah, happy to take any questions. Or Nico, feel free to jump if in case I'm missing something.
We have a question from Maria in the chat about, is Gannet an initiative of DFS or of DFS and OCHA?
No, it's DFS. Of course, we have been working with OCHA in the past in different projects, even when we were the technical implementators of the DEEP, then thinking about JOES. And the idea was to kind of bring and avoid duplications on the sector that, I mean, they happen frequently and things they already have. HDX is the largest, I would say, repository of quantitative data in the sector, and they built the Humanitarian API just to standardize somehow some of those data sets. Why not using it instead of just replicating it from our end? So, and I think, and thanks for the question. I think this is a great also moment to say we started with HAPI because it was available, it's already documented, it's there, it's public. But the idea is to expand the different quantitative sources to others. We are looking at IATI, World Bank, and others. So the idea is that we continue adding more and more, quantitative, let's say, data custodians to the system. But yeah, thanks.
Fantastic. Thank you. We have another question from Will. How do you deal with hallucination? What's the rate if you're using Claude or GPT? It can go up to 10% or higher. If it's a RAG, how do you ensure it's pulling from the right sources?
Yeah, I can start, and Nico, maybe you can complement. Hallucinations are, let's say, vastly reduced anytime that you are using RAG systems. And also because we have, first, we have, let's say, couple of verifications in the process for the prompts, the system prompts that are working in the back. I mean, this is not a pilot. This has been up and running for 2 years now. We have been capturing feedback from users, from partners that are already using Gannet in their daily kind of practices. So I think has been a lot of human in the loop and validation processes. So that's just to mention kind of the hallucination piece. If at any point there is hallucinations or something that doesn't look good, you can always report and fill out this form, and we will be kind of taking care of it. For how to select the different models, we perform different evaluation protocols inside. We know with the speed of models that are appearing and how they kind of change, we may need to kind of keep up with that. So at DFS, we have certain specific dimensions that we value for each of those models. And we also even use agents to evaluate other models. So yeah, I think it's a process. Thankfully, at DFS, we also have a team of data analysts, experts, humanitarian analysts that also validate the outputs. And with that, we keep kind of enhancing the systems. But yeah, I don't know, Nico, if you want to add something else there.
No. It's perfect. Nothing to add. Of course, as always, in those kind of application, a certain margin of hallucination can be there, but the RAG, let's say, paradigma and the report section, it's let's say the important part for try to mitigate as much as possible those issues.
Thanks.
Thank you. We have another question from Francois. My experience over the last 40 years is that the key issues are not in the data, but in the qualitative interactions and with things which are outside the data box. How do you deal with that?
Francois, can you probably elaborate a bit more on that question? If you are with us.
Do you hear me?
Yes, yeah, we can hear you.
Yes. So in fact, the data are things that we have in our questionnaires, and we know we have to collect that, and very often important things are not in the information we collect. And the more standardized we are in the data collection, the more we lose things which are site specific or cultural specific outside. So, for example, the whole issue of managing dead bodies in emergency is very often not in the questionnaires. We just ask how many people, but the social management of that is critical. In fact, even in the management of our own security, and very often this is not on board. And I have many other examples of things. So, how do we manage that? It's always a question. You give people hammers and they will look for nails. And the issue is not nails, but screwdrivers. And often, so my question is, how do we make sure that by having those kind of using the existing data, which are collected through those standardized mechanisms with OCHA, etc., Relief Web, how do we make sure that some things which are absolutely critical are not missed, and then not only missed in the collection but also in the analysis? Because if we get it wrong, then the response would be wrong, and the fact that you are encouraging many actors to join you think, which is good, mean that kind of lateral thinking, out of the box thinking will have no place. So how do we deal with that situation, with that issue of ensuring that some critical elements which are either very culturally sensitive data or information, not that, because data, information and knowledge is not the same.
Yep. Yeah.
And
Thanks, Francois, for the question. Yeah, I think it's clear now. So yeah, what we have seen is that the most that we kind of first co-create our tools or solutions with partners and with people that is in the ground, kind of they serve better purposes and they are more fit for their problems. So just to answer your question, I would say it's a couple of things. The first one, the transparency of the data that we provide, of course, is there. But second, in terms of cultural nuances and kind of that context, what we have done, for example, for the seed hub, not directly the VA, but the seed hub is being served by the Gannet, let's say, core system. Those seed hubs, and you can visit them in the website, are automated, let's say, systems, always verified by humans. In this case, we have partnered in the past with organizations that have local presence and give us kind of those specific kind of recommendations or guidance in how we can just, let's say, mitigate those potential risks that could appear from context to context. So just to say that anytime that we will be able to partner or to find local partners, if we are looking for a specific context, we'll bring them on board and we are more than happy to receive feedback from it. And the other, I would say, is also, a matter of probably thinking where to use AI and when not. So of course, right now the hype is to use AI in different kind of aspects and so on. But sometimes we just take a step back and say, okay, but if it's truly necessary here, or we just think, let's say, on a more traditional focus and approach. Just to say that maybe Gannet solves not every problem, but some of the problems that are out there. For others, we still need to kind of have that more human focus, human judgment that is, of course, necessary. And also to say AI is not looking for replacing human judgment. It's just to supporting those analysts, those practitioners that need access to more information in very kind of timely manner. But yeah, I hope I answered your question, Francois.
yes, thank you.
Thank you. I know we're at time and I feel like there's still a lot more questions. So we will be sending out a follow-up email with the slide presentations and the recording if you would like to share it with any of your colleagues. The other thing to let you know is that we will be giving free pro access to the Gannet virtual assistant for the month of March. It's a kind of our thank you for supporting us over the past 2 years while we've launched the Gannet virtual assistant and all of the products that have come from here. So thank you so much for being here. Najib, thank you for presenting, and Nico. And with that, I will close the session. If you have any other questions, feel free to reach out to us and we're happy to answer them. Thank you all.
Thanks, everyone.